They have to be secured. They have to be secured. So if you keep people out of your facility, if you keep the people out of this entire area, they don't have to be locked. They have to be secured, however you do that. Right? The advantage and disadvantage, the advantage to being locked, nobody's going to go over there and open it up improperly. The disadvantage is because somebody forgets the key, next time they leave it open, they're just going to take the lock. So you can't lock it to make it easier for them next time. So, remember we saw these yesterday? These wonderful dike tanks or tanks with the tanks with the nice built containment. And I think one of the pictures that Wayne or Dana showed had the nice little valve right here, right? And of course, always having to throw in my freaking 2 cents. Oh yeah, but sometimes you see, you go take a look at this thing, right? And you go look inside. There's a hole. You don't want to have a hole. You need to plug that thing up. All right, generator, big, huge base tank, nice double-walled tank, right? See the concrete containment? Remember, is that the required containment? That's a double-walled tank, that's a double-walled tank. No, it's not required. Matter of fact, there's a hole here and here. Is that okay? That's okay, but unless in the plan they said, we're using this curbed area for general containment, then no. Right? But they're not. There's an infiltration area that they're using. So that's fine. They have containment with a hole. That's okay. Right? Loading racks, loading arm, right? Size containment. Oh, God. Yeah. Remember, it has an arm, an articulated arm. Is that a loading rack? Yes, there's the articulated arm. Sized containment, that's a 9,500-gallon mobile refueler. There's a 10,000-gallon containment plus some additional space. Loading arm, or loading area, or loading rack? Area, right? Is there an articulated arm? No, there is a hose. Kind of containment? General. All right, you have to have some kind of overfill protection. Now, the STI folks, Dana and Wayne, hit this pretty good yesterday. Overfill prevention is really important. EPA hits this very hard in their inspections. You have to prevent overfills, but it has to be realistic, working. You have to go out there and put yourself in the place of a driver or a loader or a filler and see what you see, right? There's a number of different allowable things, and this has been harped on all week, right? Visual systems, gauges, alarms, whatever. They have to be regularly tested. So this is a 500-gallon concrete wrapped diesel, double-wall diesel tank, right? With a Morrison clock gauge. What's the level indicated on this tank? 6 feet 5 inches of liquid. That tank comes up to here on me. Now I realize this morning with that stupid ass tux I was wearing, I was tall enough where a 6-foot tank could come up to here in my BG shoes, right? But what does that tell you? Clock's not calibrated, right? Do they have overfill prevention? Not that's in compliance. So it's not good enough just to say, yep, we have it, here's the clock. It needs to be verified, and this tells me that they're not doing the proper inspections. All right? Overfill, there's a little tiny light. But the truck loading's way the hell over here, right? This is a ladder gauge, right? Just as they fill the tank, you want to make sure the gauge drops down so they can make sure that it's being filled. I can't see what this is. Different types of tank gauges, right? These guys say, okay, stop at 35, because I don't have the inches to empty, inches to full. Stop at 35. So whoever's filling the tank, click, click, click. As soon as it gets to 35, they stop. What's the question you're going to want to ask? What's the question the plan writer should ask? Yeah. Well, it doesn't matter because they stop at 35 inches. Where is the filler in relation to this gauge? Well, they're out at the truck. In that case, a two-man operation or alarmed with relays, right? In this case, they start the pump on the truck, they wheel in the hose with the handle, and they're right there at the tank. That's fine. But these are the operational questions that need to be asked, not just what kind of you have on the tank, oh, this, that, and the other. This is where operational experience comes in with your plan writer. All right? In this facility, they went beyond a clock gauge, right? And they said, okay, we're going to put a mark on the gauge. Stop filling when the gauge gets to this mark. How's that? Big hand or little hand? Go out to these tanks that have these gauges. Stand at the fill box. Can you see the gauge? Oftentimes you can't. So then they're worthless, right? These gauges indicate depth of liquid, or the depth of, or how much room you have left. What do you typically see on the fuel order ticket or on the oil order ticket when they buy stuff? How many gallons do we need? Well, why not, you call up Morrison and say, I've got X model tank, here's the serial number. They'll email you a spreadsheet for your tank. How many inches have how many gallons? If you want them to stop filling at, hell, I don't know, how about 6:30, I guess. Whatever that mark means, translate that to liquid, maximum capacity of the tank, X gallons. Again, just inherent understanding, same kind of units. Is that a written procedure? Stop filling the barrel when this pops up. Barrel is full. That is a written procedure. Is it an adequate written procedure? Yeah, it tells them what to do, right? Is the pop-up gauge working? It's working. Failure to follow procedures, what this is. The fact that they underlined it, what does this tell you? This is not the first time that's happened. You see this stuff. All right, brand new tank, clock gauge. How much liquid's in this 2,000-gallon tank? Well, it's 2 feet of liquid. 2,000-gallon tank says there's 2 feet of liquid in the tank. So we asked the guys, at the facility, this is a leak gauge, right? Said, hey, how do you guys measure? We asked, how do you guys measure how much liquid's in the tank before you fill it? Said, oh, well, we have a stick that we got with the tank. So we stick the tank, we take it up, we look at it, we take a shirt, we wipe off the stick, and I'm like, you guys know you have a gauge. That'll tell you that. We do? Thought that was a clock. When do we order fuel? Shit you not. So we take a look at the stick. Nah. Take a look at the stick. I love getting on the field. Take a look at the stick, right? How many guys have seen these sticks? Are there markings on one side of the stick? This stick is long and square-like, right? There's 3 other surfaces to write stuff on. Turns out, Convault, not wanting to waste wood because they are an environmentally conscious company, they have one stick for 4 models of tanks. Single wall 1,000 gallons, single wall 2,000 gallon, double wall 2, single wall 2. You really ought to know which kind of tank you have so you know which end of the stick to look at, right? Luckily, these guys ended up using, all right, that's 1,000 gallon, that's 2,000 gallon. Verification of operation. This is where, again, insight really helps. All right, and we stick the tank. How much liquid was in the tank? 2 feet. Hallelujah, angels started to sing. The heavens wept. The unicorn went prancing by. Anyway, inspections. You have to have written, we have to have written inspection procedures, right? We like to write the inspection procedure on the inspection form. That way they know what to look at and so forth, right? Regular inspections. The steel tank guys did a great job on this yesterday. You have to keep the records of it, right? At least 3 years. Any appropriate methods, scan them in electronic, that's fine. Right? Remember, you do have to inspect the interstitial space of a double-wall tank because you're required to inspect the outer surface of a tank for leaks, losses of oil, and the containment for the presence of oil. When you look at this tank, are you looking at the secondary containment? No. You're looking at the outside of secondary containment. Can you see the secondary containment for the primary tank? No. Can you see the surface of the primary tank? No, you have to monitor the interstitial space. So let me just blast through and show you a couple of different examples. Right? Some of these have leak sensors, some don't. They do not have to be expensive. This is a copy of the 2002 policy that says You have to monitor the interstitial space. Anybody wants a copy, shoot me an email, I'll send it to you. All right, so look, that's a high-level sensor. That's a monitor port. There's no sensor on it. Capped monitor port, overfill ports, right? There's no secondary containment monitor. Those are vents. There's no secondary containment monitor on this tank. Dike tanks, there's no secondary containment monitor, but there's provisions for it. Is there a provision to monitor the secondary containment in this tank? Where? This thing? Pull that thing out, that's a steel rod. Pull out that steel rod, that's the leak detection for the secondary containment. Pull out the rod, if it's clean and dry, tank is fine. Alternatively, you can pop one of these caps and put in a sensor, put in a gauge. But it's going to be really tough to see it well. You could. Yeah. It's easier if they could just look at a gauge. I'm telling you, and you know how it is, right? The easier you make it, the more likely it is to be done. Yep. No oil in there. It's not leaking. Yep. All right. All the fittings up on here, stuff on here, right? High-level sensors, right? Let's take a look at that. Annular space monitor. This is where a really good zoom helps, right? Are they monitoring the annular space? Nope. They need to, right? Because there's nothing coming out of the cap. This is the annular space monitor. They have a cap with duct tape on it. Let me tell you, nobody is climbing up on top of this tank to monitor it. It's not happening. If it was happening, you would see people with broken necks here. Anyway, this is a leak sensor on top of a tank. It says leak sensor, right? Warning, leak sensor goes here. Don't put fuel or nothing in it. Right? This is a leak sensor. If any liquid goes in the secondary containment, it's afloat. You'll see some red here. Some manufacturers put those on. If you had to buy them, they're like $40. $45 from BJ Enterprises in Virginia. Right? You install it in one of the 2-inch ports. Install it correctly. This tank has never been filled. Well, it's been filled once, but it doesn't leak. Right? They need to fix this. Right? But if you see orange, it's a leak. That's $50. Doesn't cost a lot necessarily, right? Generators, right? Monitored tank, right? Inner tank leak. That's it. That's the leak sensor. You need to check it. Right? Bund tank, fuel tank. There's no sensor in here. How would they monitor the containment tank to see if it's leaking? You open the plug and see. You do that enough times, what happens to the plug? It gets lost. Or it gets threaded in. What else could you do? How about if you spend $25, get yourself an acrylic drain plug, and you plug this thing in, screw this in, thread it in, use some good thread tape, right? Put this in. If you see anything in here, you have a problem, and you're done. These are $25. It does not have to be expensive. What about if it's a sensor, right? So a lot of Vita roots, right? They're connected to the sensor. That's monitored because it's got a wire, right? You look at the leaked Vita root, right? How many guys know, like for the underground tank world, you know how to check a double-walled tank? Or, you know how to check a Vita root to make sure that the liquid's in there, that the tank's not leaking, right? A series of buttons to push. Has anybody ever told you, or for a facility, what buttons do you push to see if that leak tube is leaking? Nobody. You call up Vita root, it's a 2-line instruction, and you're done. And I write that on our plans. I write that on the inspection form, right? In fact, I write that on the inspection form, right? How do you check the secondary containment in these safe waste tanks? This is the secondary containment enclosure. Level gauge, 38 inches is full. You better be scoping out down in there. Take a stick with some cotton on it. Pull it up, see if there's oil on it. Otherwise, how are you going to do it? You have to do it. Maybe put in a liquid sensor, maybe very carefully, and I don't even know if I do this, sort of, thread in one of those little liquid leak sensors down at the bottom. Do something. Do something. You can't just do it like this. Anyway, the typical inspection forms, right, with procedures. You need to have procedures. Write the procedure on the form. It's a good idea. This is one of those where this is one of the forms that we made up for somebody. Okay, look, fuel tank and annular space, right? Observe the leak gauge. See if the indicator shows any color. If it does, do this. On the gasoline tank Veeder-Root panel, press function until it shows liquid status, then press print. If the printout shows fuel alarm or sensor out, here's what it means. You have written procedures for the inspections. It tells them what they have to do, right? Anyway, yeah. 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 You do what you can. You know, there's generators where there's no way, unless you get a new generator. So we do environmental equivalence. We say, look, there's really no way to do this. So we do a really good inspection around the tank. You know, we check it for corrosion and damage, and that's going to be sufficient. That's all you could do. You know, what are you going to do? Anyway, you know, verify. We do inspections every week. I'm sure you do. You know, look at that, right down the drain. Okay, that's not a good inspection check, but there's no procedures. Just as, yeah, look at the facility. Tell us if there's a problem. Okay. Integrity testing. The Steel Tank Institute guys did a great job on integrity testing. But here and as we get done, because we're a couple slides left, all right, in your plan, all right, you plan writers, you plan engineers, all right, be specific what type of integrity testing standard you're going to use, right? And if it's a tank, anything under 30,000, 40,000 gallon shop fabricated, if you put down API 653, you should turn in your license. That's the wrong standard, right? And don't just put, we'll use the relevant standard without writing down what that is. You know, in one of the classes yesterday, somebody asked, well, what about a fiberglass tank? What about a plastic tank? What's the standard there? How do you find what the appropriate, how do you find what integrity testing standards are for a fiberglass or a plastic tank? Go to Google, and you find out that there's the Fiberglass Tank and Piping Institute that has an inspection standard for rotational molded tanks, right? The 2001-1 standard. And you call up the Standards Institute. They have a trailer in Texas. You get what you can get, right? You find what you can find, but don't just put nothing down, all right? And whatever you put down, comply with it, right? You know, this tank is, I don't know, 20 years old. It was never tested. It may have been tested when it was put in. It's probably about 20 years old. This is a 10,000 gallon and a 2,000 gallon combined tank. What's a steel tank? What's the relevant industry standard for this tank? Don't let Wayne show you up. It's after 5. The Steel Tank Institute SP001 standard, currently 5th edition, November 2011. All right. This is another reason why you want to integrity test the tanks, or at least paint them. That's a Pete Reich picture. All right, and you need to verify, right? Ask the engineer. You get your plan from your consultant or whoever's writing your plan. Read it and ask them. Say, why is this the relevant standard? Do I need to have a copy of this standard? How do I make sure I comply with this standard? You know, where it says API 653 or appropriate, I need more. What is appropriate? How am I going to prove to this to an inspector, to an agency inspector who shows up, right? Get the detail in the plan. This is from Resolve Environmental Engineering. They're a consulting firm back east. They do work all over. I pulled this off of the internet, so I know it's accurate. But actually, I looked through it, and it's actually pretty good. You know, it's actually a pretty good summary. It's not a regulation, a pretty good summary. What kind of tank do you have? Construction type of capacity. Yeah, it's shop fabricated under 50,000. You have spill control. They need to update this with the 5th edition, right? This is for the 4th edition. But spill control, yeah. Continuous release detection, yeah. SP001 Category 1 tank. Wayne and Dana did a fabulous job yesterday going through all this. But your plan should be specific. What is it? ESCI EnviroServices. You know, it should be specific, right? And your plan should detail that. This is just, and I excerpt this to show people, right? And again, Wayne and Dana went through this yesterday, depending on the size and the capacity, what category. This is from the 2004 standard, or this is from the 4th edition. But it tells you what the different integrity testing is. We summarize this in the plans when we describe what it is folks have to do. This is one for a couple of 6,000-gallon tanks. And they say API 653 will be used where applicable. That's meaningless and incorrect. And nobody should have paid an outside engineer to do this. All right, this one says, yeah, we're going to do this, we're going to do this, we're going to talk about integrity testing in this other section, flip, flip, flip. The other section says, okay, we're going to use STI, SP001, SP00103, or equivalent. This was written last year. Should have said 4th edition, right? Just another one they talk about this. This is in a relatively new plan. And actually, we're not going to go through it. That one-page double-sided handout that I gave you. Real quick, because we're pretty much done. It's a one-pager. Again, this is it's a big major food processing facility in LA next to a river. A couple of well-touted SPCC firms did the plan in 08 and in 11. They were going to have a buddy of mine who's an engineer review and certify the plan. He asked me, hey, is it okay if I do that? Let me take a look at the plan. I'll take a look, tell you if it's okay. I read through that plan, and these are the summary comments that I had on it, only looking through the plan, right? So at your leisure, take a look at it. This is what I found in a plan supposedly written and rewritten by 2 fairly well-known consulting firms that tout their SPCC experience. That plan is uncertifiable, and it doesn't meet the compliance requirements. Engineer were to certify that, they could lose their license. All right. This is an example. This is just one example. This is a plan rewritten in 2011. Why is it referencing the 30,000-gallon memo when anybody who's experienced in plan writing and should know their stuff knows that that's been replaced by SP001, 4th and 5th edition? I just get all uppity about it. This is, lastly, this is what we put for our plans that we write. We say, here's what we're going to use. We're going to use this standard for this tank. Here's the frequency. Here's the standard for these tanks. And for this tank, look, it's circa 90 to 95. Therefore, it will be tested by December 12th, 2012. And I beat on my clients to make sure that happens. This is the level of detail I think you should see in a plan. And that's just me. IMO containers, right? They have their own standards. You have to keep oil out of the secondary containment. Keep oil out of the secondary containment. Keep product tight. It's a product tight fill box. Clean that up. Clean that up. Right? Training, you have to train people. Verify. If only I had enough here to do that. You have to train people, right? Make sure people are trained and verify the training. Security, you have to have security measures, facility specific, whatever, just secure the place, right? Fence it, maybe, if that's appropriate. Lock it, certainly, right? If you're going to put a gate and a lock, make sure the gate is closed. Implementation, right? If you're going to have security, make sure it's reasonable. If you're going to, you could also secure the facility by saying, look, we have 24-hour security. They do roving patrols. We keep an eye out for unauthorized persons, but the facility isn't locked. Is that okay? Yeah, if this isn't your security. Now, my wife is here. She does not know I showed this. This is one of the fastest dogs in the world. Floyd used to clock in at 40 miles an hour. Then you had to rest. Anyway, the ultimate goal, comply, but get the inspector off your property, right? Do a good job. Write your plan so that you could read it. There's a bunch of other stuff in there, right? Make sure it's current, up to date. Make sure you're in compliance with everything. Read your plan. Be responsible for your plan. Do not let somebody hand you an inferior product. Just don't, right? Hold people accountable, right? Verify. Trust but verify. And hey, consistency, it's true. It's only a virtue if you're not a screw-up. we've always done it this way. Well, you're always doing it wrong then. All right? Anyway, you could read this later, right? Comprehensive, list everything, right? Be good, keep it updated. It's a living document. Make sure it's well organized, right? Visual compliance systems are a big help. Which one looks better? Keep up on stuff, right? Do the visual tours. That sucks. Open the hatches periodically. Clean this up. Well, that's not a compliance issue, but it looks like crap. It's going to make an inspector get the bigger red pen, right? Clean it up. You know, verify that your stuff's getting installed correctly. This stuff sat there for 5 months before some, you know, tell, hey, by the way, you may want to check that, right? Don't let this happen. This is out of the back 40. You know, well, it always weeps like that. Well, then clean it all the time. You know, make it look like you care, even if you don't. You know, well, but my plan was stamped by a PE, by a licensed PE. Just because you have a license doesn't mean you know what you're doing. Right? I have a master's license. Yeah, well, it sucks. You know, have a rule, have a plan, implement it, then you have joy. So, hey, the 2-hour class that went 3.5 hours over last time is now a 4-hour class that went 15 minutes over. Did you find value out of it? Yes. Do you think you can save money with this? Yes. Do you think you can not get yourself in trouble with this? Yes. Do you think that you're going to want to have an extra cocktail because of this? Yes. Get out. Thank you.